Hi everyone. In this video we are going to learn how to use trig ratios to find missing angles in a right triangle. So in the example we have here, you can see that we know that it's a right triangle, but we don't know the other two angles, and we have two of our sides. So the example shown, we want to find angle B, and if we look at this as our reference angle and look at the two sides that we have, the 40 would be across from it, or our opposite, and 41 would be our hypotenuse. So those two together will be a sine ratio. So we set this up, and you can see here it would look like this. Sine of angle B is equal to 40 over 41. So when we know the ratio, we need to use the inverse sine function. That's what it's called, inverse sine function. It's also called arcsine. And on your calculator, you can see what this looks like. If you look above the sine button on your calculator, right above where it says SIN, you'll see something that looks like this. SIN to the -1 power, and that just means inverse sine. If you think back to what we did on the last video, when we typed in just SIN, or the sine ratio, followed by an angle measure, it then gave us what the sine ratio was. When you use the inverse sine function, right after that, you type in what the actual ratio is, either in fraction form or decimal form, and then when you hit enter, it's going to give you what the angle measure is. You can also find the inverse sine function on Desmos. If you have your computer out and want to find it, I'll tell you exactly where to go. So on the bottom of your Desmos screen, there's a little keyboard button. If you haven't clicked that yet, click on that so that the keyboard buttons come up. And then there is a button that says function. If you click on that, a whole list of different functions come up, and you'll find all the trig functions here, and also the inverse functions are there as well. Okay, so either on your calculator or on Desmos, type in the inverse sine function. Again, on the calculator, use second and then the sine button, or on Desmos, you can just click on it. And then inside the parentheses, you can type in the ratio that we want, which is 40 divided by 41. You don't even have to make it a decimal first. You can just type it in just like that. Just end the parentheses when you're finished, and then press enter. And you should get the answer of 77.3 degrees. I should have also said at the beginning of this to double check to make sure your calculator and Desmos is in degrees. So if you got a different answer, then your calculator or Desmos is still set up in radians. So just a reminder of how to check that. Click on the mode button at the top of your calculator and double check that it's on degrees. On Desmos, if you click on the little picture of a wrench in the upper right hand corner, at the bottom of that little pop-up window, you'll see a choice to change it to degrees. So if you didn't get the right answer, try it again, and make sure you get 77.3 degrees for the sine ratio of 40 over 41. Okay, for these questions, you'll notice a symbol that you probably haven't seen before. This symbol here is one of our Greek letters that gets used a lot in geometry, and this symbol, you would call it theta, which is THETA. That's how you say that, but it's theta. And we often use the theta symbol to represent a missing angle. You could say something like tangent of angle X or tangent of angle A, but you'll also see theta there. It's sort of like a zero with a line through it. When I write it on with my own pencil rather than on the computer, it often looks like this. So it's sort of a circle with a loop coming through it. Okay, so these questions are asking us to first draw a triangle to represent the given ratio, and then we're going to use our inverse function to find the actual angle. So let's go ahead and draw a right triangle. Don't worry about what the other side lengths are. It doesn't matter if it's not exactly matching the lengths that we have. Just draw a right triangle, and let's pick one of our angles to call theta. I'm going to pick this one here to call theta. And we want the tangent of that angle to be 1/3. So remember, tangent is opposite over adjacent. If you can think of your SOHCAHTOA in your head, so TOA, opposite over adjacent, that means the opposite would be 1 and the adjacent is 3. Okay, so next we want to use our inverse functions to go ahead and find the angle measure. So on your calculator or on Desmos, go ahead and use the inverse tan button. So it looks like this, the tangent of -1. And then in parentheses, we're going to put this ratio, which is 1/3. We're going to round to the nearest tenth, and so you should get 18.4 degrees. All right, for our second one, let's go ahead and draw a right triangle again. And let's pick our angle to be theta. And this time we're dealing with a sine ratio. So think about SOHCAHTOA. So we're dealing with opposite over hypotenuse. And so from our reference angle of theta, the opposite will be 12 and the hypotenuse will be 13. Okay, now to find the actual angle measure, we're going to use the inverse sine function. So either on your calculator or on Desmos, you're going to type in or choose the inverse sine function, and then in parentheses put 12/13, and you should get to the nearest tenth. It'll be 67.4 degrees. Okay, on to our last part of this question. Let's go ahead and draw our right triangle in. Just to be different, I'm going to make this one our reference angle, or our theta. And we want the cosine of theta to be 7/8. So cosine, SOHCAHTOA, that's adjacent over hypotenuse. And our adjacent will be 7, and then the hypotenuse will be 8. Okay, now to find the angle measure, we're going to use the inverse cosine function. So we type in to either Desmos or your calculator the cosine function of 7/8, put that in parentheses, and to the nearest tenth of a degree, you should get 29.0 degrees. Okay, here's 3 more just to practice a little bit using your calculator or Desmos to use the inverse functions. So here I've given you the actual ratio as a decimal, and you're just going to type that in just to practice doing that step. So I've shown you here in this picture what it looks like on Desmos. So this is if you were using Desmos to do the inverse sine function, this is what it would look like. It's almost the exact same thing on the graphing calculator. It just doesn't look quite as pretty as this, but it'll look the same thing with the same letters and the same numbers on your calculator. So go ahead and type in your inverse sine function, followed by the decimal 0.4771, and hit enter. And we're going to round to the nearest degree this time. And you should get 28 degrees. All right, go ahead and do the next 2 by yourself, either using the calculator or Desmos. So pause the video, try those 2 by yourself, and check back in a second to see how you did. Okay, so hopefully you got 44 degrees for the cosine and 85 degrees for the one with the tangent. All right, so here's a couple questions. What we're going to do sort of start to finish, where we have to find one of the missing angles. We have to figure out which trig ratio to use, set it up, and then use our inverse trig function to find the missing angle. So in the first one, in number 3, we want to find angle M. So this is our reference angle. And with the 2 sides that we know, 37 is obviously a hypotenuse and 12 is an adjacent. So adjacent hypotenuse, that's going to be a cosine ratio. So we set it up as the cosine of angle M is equal to the adjacent, which is 12 over 37. So on your calculator or on Desmos, we want the inverse cosine function. So we have cosine of -1 of the fraction 12/37. And if you want to, you could certainly type in that fraction first and get the decimal, but it's just an extra step. You can put that fraction right into the parentheses and figure out what the angle measure is going to be. Let's round to the nearest tenth here, and you should get that the angle measure is 71.1 degrees. Okay, and our second one, we're going to find angle H. And the 2 sides that we have an opposite this time. This is opposite. and an adjacent. So opposite and adjacent, that's going to be a tangent. So we're going to set it up as the tangent of angle H is going to equal the opposite, which is 3, over my adjacent, which is 4. So then we want to change it to the inverse tangent ratio of the fraction 3/4. So go ahead to your calculator or Desmos, type in the inverse tangent function of 3/4, and we should get that it is about 36.9 degrees. All right, go ahead and do angle U by yourself. So set up your ratio for angle U, pause the video, and come back and check on a second. All right, so I got 53.1 degrees, and I hope you did too. If you didn't get that, just check that you did use the ratio of 4/3. Maybe double check that you are in degrees instead of radians, and then of course that you use the tangent ratio for this one. Okay, for this question, we're going to find angle Z, and you'll notice that we have all of the side lengths here. So when we're trying to figure out which trig ratio to use, we could actually use any of them. We have enough information to use the sine, the cosine, or the tangent. It doesn't really matter. When we have all three side lengths, you get to have that choice. So if you notice, we're going to actually do it once, and then we're going to do it again using a different ratio, just to check that we have the same exact answer, because it shouldn't matter which ratio that you use. So let's just go ahead and use sine for the first one. And so for angle Z, opposite of angle Z is 8, and the hypotenuse is 17. All right, so let's set this up to say that the sine of angle Z is equal to opposite, which is 8, over the hypotenuse of 17. And then we change this to the inverse sine ratio of the fraction 8/17. So we're going to type that into either Desmos or your calculator. So the inverse sine ratio of the fraction 8/17, and that should come out to about 28.1 degrees. Okay, so next I want you to pause the video and try it a second time using a different ratio. You can either do cosine or tangent, it doesn't matter. You only have to do one of them, and we should get the same exact answer. So go ahead and do that and check back in a second. Okay, so I went ahead and did both of them so you could check either one that you might have done. I showed the cosine ratio here and how it would set it up, and you would get 28.1 degrees, and then here's the tangent ratio, and again getting the same answer. Okay, in our next question, we don't have a drawing. We're going to have to draw it based on what they've told us, and it says triangle PQR, angle R is 90 degrees. Let's go ahead and draw a right triangle and label it so that angle R is 90 degrees and angle P is 27 degrees. And we also know that QR is 5 centimeters. And they want us to find the length of PR. So this is actually using what we learned in the first video of finding a missing side length. I just wanted to throw this one in there to practice that so you didn't forget about how to find a missing side length given the angle measure. And so if this is our reference angle, we have 5 is our opposite, and that makes X our adjacent. So O and A goes together for SOHCAHTOA, that's a tangent ratio. So we set this up as the tangent of 27 degrees. So now we know the angle measure is equal to our opposite of 5 over the adjacent of X. So this is where we will not use the inverse tangent. We're just going to type in the regular tangent. So on Desmos, you can just type in TAN, or you can click on functions and click on the tangent ratio, or on your calculator, you can just hit the tangent button. So we're going to type in the tangent of 27 degrees, and we should get the decimal 0.5 0.095, and that equals 5 over x. And remember, when x is in the bottom like this, the easiest way is to just make it over 1, make it a proportion, and cross multiply. That gives me 5 times 1, or 5, equals 0.5095x. We divide to get x alone. And that tells us that x is approximately equal to 9.8 centimeters. All right, our last question. So here we have a sort of application problem of thinking about a ladder again. We have a ladder leaning against a brick wall. The foot of the ladder is 6 feet away from the wall, and the ladder reaches a height of 15 feet on the wall. And the question is asking us to find, to the nearest degree, the angle that the ladder is making with the wall. Notice where that angle is. If this picture wasn't there, would you have known that the angle they want us to find is this angle here? This is the angle that the ladder is making with the wall. The question would have been, or the picture would have been different if the question had been, find the angle the ladder makes with the floor, with the ground. Then that would have been this angle down here. So just make sure that that makes sense, because sometimes this question will get asked without a picture and you have to draw the picture yourself. Okay, so we want to find angle x, and the two numbers that we have an opposite here, 6 is an opposite, and then our 15 is the adjacent. We don't have the hypotenuse. So we're going to use the tangent ratio. I'm going to let you try this one on your own. So you're going to set up a tangent ratio, and then use the inverse tangent function to find the missing angle. So go ahead and pause the video, finish this question, and come back and check in a minute. Okay, so hopefully you set it up like this and you got the angle measure to be about 22 degrees.